Okay, so this is Investigation 2.2 in Lesson 2, Matter and its Interactions. And this is kind of a two-part investigation. At first, we just have to make physical observations of a few powders. Four known powders being table salt, Epsom salt, borax, and citric acid. And then we have a mystery sample that we have to make observations about. And then the second part of this observation is that we are going to dissolve those substances in water, and we're going to keep adding scoops until the water does not dissolve it anymore. So basically, in this investigation, you will observe the physical properties of four known samples and then a new mystery sample. Each of the solids you will use in this investigation is a crystal. A crystal is a solid that contains atoms arranged in an organized way. Crystals are also called crystalline solids. So the first part of this experiment, ignore this picture. I don't know what this is for. If you guys were doing this in class, I would give you a black piece of construction paper and ask you guys to label, make a label for each of the crystals that you are given. In the first part of this investigation, you have to look at each of these crystals and make two physical observations about them. So when I press play, it's going to go to each of these, and you have to make observations of each. So table salt. Oh, those go fast. This is Epsom salt. This is borax. And then we have citric acid. So in that first chart of the investigation, make two observations, descriptions of these four, and then we have a fourth mystery D powder. So this is what all of them look like all together on the construction paper. So you will see after you fill out the observation chart, based on your observations, there's a question that will ask, how is the mystery sample similar to the known samples and how is it different? So if you need to go back and view any of these again, you're just going to have to rewind the video. So it is definitely possible that the mystery sample has the same structure and is made up of the same atoms as one of these known samples. At this point, next question on your worksheet, can you match the mystery sample to the known sample based on appearance alone? Why or why not? So I guess I can make it go back a little bit and we can look at each of them again. Way too far. Okay, so we have table salt, Epsom salt, borax, citric acid, and our mystery D. Does our mystery D look like any of the others? Okay, so in the next part of this experiment, or investigation, sorry, we are looking at the solubility of each of these. Solubility is a physical property that describes the amount of substance, so the amount of these crystals that can be dissolved into another. So we're going to be taking these 5 crystals and we're going to be dissolving them in water. And you will see that in your worksheet there is a chart where the way to test solubility is to keep adding water or keep adding the crystal to the water until it will not dissolve anymore. So in this video, he just puts 1 scoop in each, but if you were doing it in class or watching the demonstration during Zoom, we would have to continue adding scoops until the water does not dissolve the crystal anymore. So something that's very important is that the exact same amount of water is used in each of the experiments. So you will see that he uses a graduated cylinder with little notches on it to make sure that the amount of water that he's using is the exact same in each. So pressing play, you will see that he will dissolve each of the 4 using the 20 milliliters. So every single time he's going to use 20 milliliters. And then the scoop is going to be the same for each of them. But the reason why he just mixes 1 scoop for us to see is because it's just looking at like how easily it dissolves. So that's what I want you guys to be watching when you watch this video. When he shakes it up, how easy does it seem like those crystals break apart? So when he gets done shaking it, make an observation or look and see whether there's any of that table salt left. So again, same amount of water. And then same amount in the scoop. And these already, based upon like how big they already look different within that test tube. So shake, shake, shake. Still shaking. So when he gets done shaking, what you want to think about is how does this look compared to the first? Is it just as clear? Is it not as clear? So now he'll do borax, same amount of water. Same amount in the scoop. And then, I don't know if you can remember, but Epsom salt seemed to settle down at the bottom. Well, I don't quite see a whole lot settled or stuck to the bottom in the beginning. So let's see if he has to shake as long as last time. Don't think he had to shake quite as long as last time. And this one doesn't seem as clear as last time. Then we have citric acid, same amount of water. Same amount in the scoop again, because those have to be exactly the same in order to be able to compare them. So the amount of water and the amount in the scoop are controlled variables. Think more shaking than the last time. Might look more clear than the last time, I think. And then we have the last mystery D sample. Shake it up. Crystals definitely are not as big as the Epsom salt. The Epsom salt seems to have the biggest crystals. So it's probably not that one. So looking at this one, it looks pretty clear. So remember, one of them was kind of fuzzy. I believe borax resulted in something kind of fuzzy. So if he had done the full solubility procedure, what he would have been doing is he would have kept adding scoops until the crystals no longer dissolved in the water. So the chart that asks about solubility scoops, how many is added until it will no longer dissolve, these are your answers to that chart. So table salt at 4 scoops, it stops dissolving. Epsom salt, 5 scoops, it stops being soluble. Borax, 2 scoops, and it already, you'll see chunks. Citric acid, after 9 scoops, it'll start looking chunky instead of dissolving. And then mystery D sample, 4 scoops before it starts becoming chunky and not wanting to dissolve. So the last questions to think about are based upon this. Can you identify your mystery sample? Why or why not? And if you can, what do you think your mystery sample is? So do you think your mystery sample could possibly be the same as one of the others? So would it have the same solubility? And then the last thing you need to think about are what are some physical properties you observed during this investigation? And then what are some potential everyday uses based upon those properties? So go ahead, watch, rewind, um, move this recording video around as you need, but it's not quite the same as seeing it in person, but you will be able to get the assignment done by watching this video. So thank you guys. Bye.